right? So here's an example from 2007 from the SIGGRAPH conference. This is something called the scene completion problem. Okay, so somebody took this photo. Somebody was traveling in Europe somewhere, and they took this photo. Right? When they took this photo of this nice, beautiful lake, somehow there was this house that kind of came in the way, right? So they wanted to get rid of this house from the picture and just have the view of the lake, right? And was this working? Right? So you just want a view of the, you just want to cut the house out of the picture. But when you try to cut the house out of the picture like that, now the picture has an incomplete part to it, right? So you want to complete this incomplete part with something that looks like the rest of the picture. This is called the scene completion problem. So you want to make this picture look natural. I've just cut out a piece of the picture, now complete it and make it look natural, right? So that's the scene completion problem. Now there's lots and lots of ways of tackling the scene completion problem. A lot of it involves having a lot of domain knowledge about the kind of pictures it is, about the sky, about the lake, about people, involving very, very complicated scene analysis software and so on. But these two guys, Hayes and Efros, they decided to try a different approach. They said, can I use an approach that uses a lot of data but very little knowledge about the world, right? So what they did was they went to Flickr, which was then the biggest source of images. Flickr has billions and billions of images. Now they are bigger. Now Instagram's probably bigger. But Flickr in those days was really big. And it had billions and billions of images. And they said, look, let me go to Flickr and let me do a very simple search algorithm that takes this image and using a few parameters, it tries to find images in Flickr that are similar, that are near neighbors to this picture, right? So they went to Flickr and searched through those billions of images, and what they did was that they identified a few other images as being near neighbors or near duplicates of that image that that they started out with. And when they did that, they picked one of those and they completed the picture. They took the nearest image from there and they completed the picture, and this is the picture they ended up with. Okay, so you fill in the picture very nicely, right? By using a very simple algorithm, you've sort of solved a very complicated problem, right? You've not tried to understand the world. You've not tried to understand what sky is, what light is, what color is, what anything is. All you've done is go to a large repository of images, find a similar image, take a piece, and stick it in here. And voila, it works really well, right? So that's kind of the solution to the scene completion problem, which I'll call kind of a big data approach to this problem, right? Which is just find a large source of data that has similar things and take data from it and stick it in there, right? So, and just to illustrate this, right? Suppose Flickr has billions of images, but suppose I only take 20,000 of those images, and I take my image and I try to find the 10 nearest neighbors to that, right? You can see that these are the pictures that I get, and these don't look that similar, right, to the image that you care about. But on the other hand, if you use all of Flickr, just 2 million images, let's say, and you find the nearest neighbors, you'll see that these look much more similar, right? When you increase the amount of data that you're searching over, it's more likely that you'll find something that's a better match, right? It should be something very obvious, right? The more data you search over, the more likely it is to find something that's a good match to what you're looking for, right? It's a very, very, very simple system, and in fact, the image that used to complete that scene came from here, that picture there. So basically the idea is to just use a large source of data, and the more data the better to solve the problem. So you convert a complicated image understanding problem into a simple search problem. This is what I call the big data approach, right? The big data approach is about simple algorithms with access to large data sets, right? Don't put a lot of sophistication in the algorithm, but try to use as much data as possible use simple algorithms with access to large data sets to solve really complex problems, right? So this is kind of what I'll call the big data approach. And I think you'll sort of, this I think is a way to succeed in a data-rich world, right? If anybody asks you to try to solve a problem, think about where is the maximum amount of data available to solve this problem, and how can I search that data in the fastest way possible, right? And there's probably a solution, a simple solution that'll present itself to the problem. And this is kind of what I, what I sort of call, by the simple phrase, more data beats better algorithms. And the idea is that, if you sort of use the current set of algorithms are kind of data poor and model heavy, and they're like the hair, right? It runs really fast initially. The new kind of approaches, which are kind of data rich and model light, right? They're much poorer than the data poor and the model heavy approaches, but over time they actually beat the data poor and model heavy approaches. They're like the tortoise, right? So start slowly but end up being the winner. So I think over time you'll see more and more of these data rich and model light kind of approaches. For example, one of these data rich and model light approaches is if you use Google and Google has ever corrected your spelling while you're searching, right? Google spelling correction is an example of a data rich and model light approach. Google spelling correction knows very little about the English language. It just searches looks at other searches that are very similar to your search and uses those suggestions, right? So that's an example of a data rich and model light approach to solving a complicated problem. So that's kind of the second part of my talk, right? About how to succeed in a data-rich world. Moving on to the third part of my talk, the conclusion, and wrap up about how the world is going to be, what the next revolution in the world is going to be. So this guy, his name is guy with a big mustache. His name is Tycho Brahe. How many of you have heard of him? A lot of people, man. Okay, when I give this talk anywhere else, nobody's heard of this guy. Okay? At IIT, everybody's heard of this guy. So what this guy, Tycho Brahe, what he's famous for, he's lived in the 15th century. What he really did was he actually created the first database in the world. Okay? So people don't realize it, but he was the first database administrator, created the first database of the world. The database that he created was about the planets and the moons of Jupiter and so on. He observed them, and he created this almanac where he recorded the positions of various celestial objects over a large span of time, right? So that's what Tycho Brahe did. He created the first database in the world. So once Tycho Brahe created the first database in the world, this other dude came along, Kepler. He analyzed all the information. What did he do? He came up with the laws of planetary motion. He used all this data, right? He built a model on top of the data, and that model is what we today call the laws of planetary motion, right? He figured out that planets move in ellipses around the sun, and you studied all this stuff, right? So then this other dude came along, Isaac Newton, and he looked at the laws of planetary motion. He said, I can simplify all of this stuff. I can represent it as some, couple of basic laws. And there you have it. And using these laws, that remember all this started from that database, right? You start from a database, you do data analysis, you build a model, and now you have these laws, right? Now using these laws, you can solve JEE problems, right? So that's so using these laws, practical application, you can solve JEE problems, but you can also launch rockets and other trivial applications like that. So you can do interesting things, right? So why, one of the interesting questions to ask is, why did people like Kepler and Newton, and if you think about the last 200, 300 years of human civilization, right? They've been driven by pretty much these laws of motions that were discovered by Isaac Newton back in the 1700s, right? The whole industrial revolution started because of this. The whole of history, as we know it, comes from here, right? So the question to ask is what the trigger for all this, right, was not something that was on the Earth. It was something that was in the stars. It was the position of the planets and the position of the moon and the position of the moons of Jupiter and so on, right? So the trigger for modern civilization and the Industrial Revolution was data. But it's not data about the Earth, it was data about the skies, right? It was data from from an astronomical source. And the whole of modern physics is based on that because that was the only data that was available. That was the data that was easy to collect, right? So the world takes data that's easy to collect and builds interesting things out of it, right? In some ways, if you sort of think about it, the astronomical data sort of unleashed the Industrial Revolution, right? For the first time today, right? I mean, just in the last few years, the kind of information that Isaac Newton had access to about the stars and the planets, we all are starting to have access to about ourselves, about the human race, about people, how they behave, right? We never had access to data. We knew more about the moons of Jupiter than we knew about how crowds of people behave, right? But now we are starting to understand how crowds of people behave. We know how revolutions happen, right? We know how social organizations happen, right? How do people react to certain stimuli? We understand more about people now, right? Because of social media, because of the internet, right? Because we're sort of gathering data about people at a mass and large scale that has never been done before, right? Now we have the data, right? Just as the data about astronomy created a revolution in physics and the physical sciences, Twitter and Facebook and Wikipedia and so on, we are at the cusp of a revolution in the social sciences, right? If you sort of, how many of you have read the Foundation series, Isaac Asimov's Foundation series? A few of you have read it, right? So a key thing in Isaac Asimov's Foundation series is a science called psychohistory, right? Psychohistory was the science where you could, somebody could predict history, predict how the world would unfold based on all the, things that had happened until that point, right? We can predict where the moon is going to be and where Jupiter is going to be at a given point, but we cannot predict, what's going to happen in the world tomorrow, right? And that's going to change. Because of the data that, because of the data we have from social media, because of the data we have from mobile and so on, we're going to be able to predict human beings and we're going to be able to predict the world, in our world, people in a much better way than we've ever been able to do before. And I think this is where the next revolution is going to be. It's going to be, the next revolution is going to be the social, the last revolution was the physical sciences, the next revolution is going to be the social sciences, and it's all going to be because of data. So I'll leave it there. Thank you. Questions?